All right. Yep. So with that, I will get started. So welcome to everybody who is either returning or new or just interested. This will be our first general meeting of the year. So yeah, let's get started. Okay, so just a little bit about our club and its background. So space used to only be accessible to big companies, but things are getting much simpler and easier to do. And with that, pretty much anybody with the resources and the interest can send stuff into space. So that is the ultimate goal of Bruin Space, to build a fully functioning satellite. And each of our projects kind of helps us to develop the skills and work towards that goal. So that's kind of the mission of Bruin Space. Through each of our projects, we develop the skills needed to build a fully functional spacecraft. So next slide. So getting right into it, some of the changes that we'll be seeing this year, sadly, due to everything that's going on that is affecting everybody, there will not be any in-person work or lab access until UCLA gives us some actual direction. So that's very unfortunate, but we are accommodating for that. So all of the work for each project will be done remotely, and with building spacecraft, that's kind of hard to do because there's a lot of hardware that has to be done with that. So we are working on exploring some options to maybe like ship out hardware to individual people, and so that people can work on it from wherever they are and then ship it back. So we are looking at some different options, but everything is still kind of up in the air, and we don't know how long anything will be going on for. So there's a lot of stuff to look at, but just some general information on what changes are happening. So next slide. And then finally, we up until recently, we have been using Slack for all of our internal communication, but like a couple weeks ago, we switched over to Discord. So all of our communication is in Discord. If you are not already in the Discord, you should join that. There will be a link at the end. And yeah, so all of us leaders will be around for any support or any questions that you may have. But that's a pretty big change, and trying to make it go as smoothly as possible. So now we'll kind of get into some information on each project, just so that everybody has an overview of those and can see what more specifically our club does.
Okay, so this year for Forge, so Forge is our workshops program.
But who are you?
Yes, hi, I'm Zephyr. I'm about to say that. I'm the lab manager this year, and I'm handling Forge, which is our workshops program. Obviously, it's a little bit tricky having no physical lab space, but there's still lab type stuff that we can be doing. So here's our tentative plan for fall workshops. As you can see, we've got 4 workshops planned. We're looking at systems design, circuit design, CADing, and radio work. So there's some intro type projects. The idea with each of these is that you come away with a small project that you've walked through entirely and completed. And so yeah, lots of cool stuff that you can work on. Finalized information for each of these will be sent out by the Wednesday before the workshop. So like this is not yet set in stone, but this is kind of our plan for fall. These workshops are standalone. Attend as many as you like. Hopefully, show up for all of them. And what we will be doing for at least some of them is hopefully creating projects that you can then go ahead and apply for later workshops as well. For example, the circuit you develop in Tinkercad will hopefully be something that you can then later on create a PCB for. So yeah, that's the plan for workshops. All this will be announced as well on the Discord, which we'll be linking to shortly in the chat.
Hello, everybody. My name is Lorraine. I'm a third-year astrophysics major, and I'm the project manager for Overseer. Ethan is our chief engineer, and you will hear from him in a little bit. But yeah. So Overseer is our high altitude balloon project. And high altitude balloons, if you don't know, they allow us a quick and affordable access to the gateways of space. Our balloons actually go up to about 100,000 feet into the atmosphere, which is considered the stratosphere. So it's pretty high up there. And this is our entry-level project. And as that, our mission is to establish a durable, modular, cost-efficient method to build high-altitude balloons for use in scientific research at UCLA and beyond. So basically, we spend all year building this payload to be attached to this balloon, as you can see in all the pictures. And then at the end of the year, we drive out to the middle of the desert, launch the thing, and chase it around for a few hours. And it's a bunch of fun. Next slide, please. So our team is structured in a few different sub-teams, depending on what your interests are in. Our mechanical team focuses on designing, 3D printing, and assembling our physical payload. So in the bottom picture, you can see like the orange structure, that's the payload that the mechanical team works on designing. And if you end up joining this team, you will gain skills in AutoCAD and also 3D printing and a few different like physics principles. The electrical team works on designing and assembling the circuitry, fail-safe, and power source for our Raspberry Pi, which is the main microcomputer that we use on our payload. So if you're interested in electronics and you join this team, then you will gain skills in circuit design and also become knowledgeable of the Raspberry Pi and a few different microprocessors. Our software team help to facilitate interaction between the electrical and mechanical components of our balloon through code. So all of our computers on our payload need some type of code to tell it how to run, and that's what the software team does. These members learn skills in Python and also using version control because GitHub is like our main spot. And then finally, the communications team designs and builds an efficient tracking system for a high altitude balloon so that when it's up in the sky flying away, we can track it in the desert and then hopefully recover the payload in the end. So if you join that team, you will gain skills in ham radio, antenna design, and basic circuitry. Next slide. So now I'm gonna hand it over to Ethan. Go ahead.
Well, hello guys, my name is Ethan. I'm a third-year bioengineering major, and I'm also the chief engineer of Project Overseer this year. So I want to talk to you guys about some of the development plans we have for this upcoming year. So in general, for all four of our sub-teams, we're just going to be working a lot on, improving reliability, improving our ability to get the best data we can. And there's just a whole bunch we can do, but we've kind of outlined 4 specific goals for each of the sub-teams. For mechanical, what we really want to do is expand modular design to include a second payload, which will make adding extra sensors really easy in the future. That way, 5 years down the line, it's really easy to decide if you want this new cool sensor on our balloon. It'll be really easy to add it. You won't have to worry about tinkering with the code. With our electrical team, we want to explore the addition of adding solar panels to sustain the battery life to allow for longer flights, more reliable flights. And that's also if we end up losing the payload, trying to track it down, it won't run out of battery while it's on the ground. If it's assuming it's still daytime, it can get enough energy to keep pumping signals to us. For our software team, we were looking into creating a geofence. What a geofence is, it's a way to allow the balloon to essentially know where it is and know places that it might not be able to travel, which we could link up to some sort of fail-safe mechanism, allowing it to pop and avoid landing in places such as like a military base, which may have happened in the past. That way we can always make sure we can get our balloon back. And then finally, for our communications team, just in general, we are working on just increasing the reliability and the simplicity of the telemetric communication system we have by just looking into different types of communication systems and finding out what is the best way to actually communicate.
They once lost their weather balloon inside a military base.
Oh no.
That may or may not have happened. Join the team, you can hear more stories about it. But yeah, we're just trying to increase reliability virtually in all 4 of these major areas. What kind of communication systems are you planning? We're working a lot with APRS technology. It's just basically pretty, I would say, relatively simple means of communication. We're not getting into anything super, super complex, but we're working a lot with just various types of antennas and a couple different types of protocols and how to basically communicate with this balloon. But yeah, you'll be exposed to a whole bunch of different types of communication on this team. Okay, so, and I want to talk a little bit about the timeline and also what we plan to do with COVID-19. So we've kind of considered Overseer to be a safer at home project, which means that everyone can work meaningfully on this project no matter where you're living. So this is great for anyone who's not currently on the UCLA campus or anyone who doesn't plan on coming back for the school year. And we specifically wanted to implement this by using tools that are all online and all have shareable files, which is such as AutoCAD Fusion 360, which allows for really easy integration of different people's teams. Tinkercad is super useful for exploring different electrical circuits. And also we're going to expose you guys to GitHub on the software team, which allows you to communicate codes and create different branches. So these are all things that will tangibly allow us to work on our balloon, but won't really require us to be in person. And to just look briefly at the timeline, fall quarter, we actually have for this year, we're planning on really working on teaching. So we're going to do a lot of remote training for the first 6-7 weeks, meaning we have slides presented where we'll be able to teach you guys the basics of every different element, whether that be from the electronics, the software, or really anything else. We'll be able to teach you guys, meaning you don't need to come in with any prior knowledge. We're happy to teach you everything. And then towards the end of fall quarter, if we have time, we can start getting some work done in our development. In winter quarter, we're going to work much more on development, all remote, all online, and testing as best as we can online. Or if we're going really quickly, we might be able to do some in person with the people that are on UCLA's campus as safely as we can do it, in small groups, of course. And then spring quarter, we're aiming to have fully in-person testing and building, launching, and remote updates. And by this, we're going to have, again, very small groups without lab access, but we need people to be able to put the balloon together, make sure all the parts fit, everything works. And, hopefully we're going to have access to the lab spring quarter. We really don't know yet. And then, of course, we're going to have the launch, hopefully, if everything goes well at the end of spring quarter. And that's always a really fun event. So, yeah. And if you guys have any questions about it, we're going to have a little Q&A session at the end, or you can just put it in the comments below.
So hopefully we've convinced you that Overseer is a lot of fun and also a very meaningful project to join. If you are interested in joining, the time commitment for this project is about 0 to 3 hours a week per each sub-team you join. So you can join multiple sub-teams as long as you can fully commit at least up to 3 hours per sub-team. And the Zoom link for these weekly meetings will be posted in the Discord. So definitely make sure you're on the Discord because that's where all our communication will be. We even have some leadership positions available for people who are especially skilled in electrical design and radio communications. So if that applies to you, please reach out to me because we do have some leadership positions for you. And don't forget to fill out the application, which I think we're going to send out at the end of the meeting. Our first all hands meeting will be next week and the information will be in the Discord. So keep your eye out for that. And yeah, like Ethan said, if you have any questions, our contact information is on the next slide.
Thank you, guys.
All right, hello everyone. My name is Raymond. I am a 4th year physics major and I am the project manager for Project Endeavour. So the easiest way to sum up Endeavour is that it's the science team. It's the science-oriented project. The other projects are more engineering focused. This is the basically data taking, data analysis team. So the main focus is scientific experimentation. We start off with experimental design. We take our own data. We process the data and analyze it. And the end goal for all of our projects is the publication of said data, either by submitting it to a database for credit by others or writing and publishing our own paper in a journal. And I have this thing here, prerequisites. There are really no prerequisites, but you need to be willing to learn anything necessary to furthering the project as needed. All right, next.
Did we lose him?
Yeah, I think he's frozen. Oh,
All right,
Raymond,
yeah,
welcome back.
yeah.
You froze.
Yeah, so my internet disconnects like every 15 minutes for some reason, and I don't know why that happens, but I haven't found a solution to that yet. So, all right, so first off, I'm going to give like a rundown of some of the projects we worked on last year. And the reason why I do this is because these projects are not necessarily finished. They are indefinitely on hold due to the COVID situation. It would be nice to finish them if the situation improves. So if you're interested in either of last year's projects, then please contact me. So the first of these projects is the muon detector. So as the name suggests, it detects muons created as high energy cosmic rays collide with molecules in the atmosphere. This creates shower particles, some of them are muons. And the muon detector, when placed at different altitudes, can be used to determine the altitude dependence of muons. And that altitude dependence can be used to support the theory of special relativity by confirming time dilation effects. So before COVID happened, this was mostly finished and needed a few extra parts, and the plan was to fly this on Overseer when that's balloon launched in spring. That was delayed, and so this project can't come to fruition until Overseer launches, basically. So this project is on hold. It may be revived whenever necessary, so be aware of that. All right, next slide. The other project we did last year was an analysis of the magnetohydrodynamic pump. Basically, that just means it's a pump that uses magnetic and electric fields arranged perpendicular to each other to propel a conducting fluid using the Lorentz force, and has applications in space because it does not need moving parts. The end goal of this, as with all of our projects, is publication of these results and a comparison of our pump results with simulations made in ANSYS Fluent. So prior to COVID, we were figuring out how to mitigate effects of gas buildup in the system caused by electrolysis. And we were looking into building an AC pump. After COVID, status is uncertain. We can resume this if people are interested. It will be more difficult without access to supplies or the lab, but yeah. All right. So for this year's project, I was basically trying to find something that's science related but doesn't require us to build our own instrumentation because of COVID, obviously, and the need to work from home, and also because I'm a senior and I didn't want to start a project that will require like in-person lab access that might never occur this year. So basically, my plans for this year are a remote telescope project. The name speaks for itself. Basically, there are telescopes all around the world that you can control from your laptop or wherever. They're in Chile, the Canary Islands, Australia, New Mexico, and so on. And they can be used for imaging and collecting astronomical data, such as astrometry, aka position data, photometry, which is brightness data, spectroscopy, and so on. And the plan for this project is to collect and analyze data pertaining to minor planets, comets, and asteroids. This data can be published in MPEC, aka Minor Planet Electronic Circulars, or it can be used as part of a separate research paper. So the picture here is of a comet that appeared in 2018. This was taken using one of a series of remote telescopes in Australia. Next slide. All right, so there are a few directions we can go with this project, but the main idea is to take position data and brightness data of a variety of objects, comets and asteroids, and then submit them to the Minor Planet Center, aka the MPC, which is where all this data is typically stored. This data can then be accessed by researchers who can then use that data for their own purposes. If they use a position data, you can get an acknowledgement in a paper. If they use your images, you can potentially get a co-authorship in a paper. So we want to take as much data as possible, create some light curves, look at the several physical parameters pertaining to comets, such as the AF-rho parameter, with rho being the Greek letter rho, which determines dust abundance in comets. We can potentially explore the phase effect, which occurs when comets at low phase angle, aka viewed head-on, appear brighter due to scattering from dust. And there's also the potential to use these telescopes as a sort of survey for new comets and asteroids that we can report to the Minor Planet Center, which is nice. And there are plenty of objects that can be the subject of a more detailed research study. I have two here, 7P Pons Winnick, which is a comet, and C2017 K2 Pan-STARRS. So yeah, that's some of the plans for this year. All right, so basically, if you're interested in the project, the time commitment should not be too much, since there will be focus early on automating most of the data collection and data processing procedures, so that we don't have to do that manually. Some contact information. There's me, the project manager. That's how you can find me in Discord, and there's my email right there. We will have an informational meeting for anyone interested sometime next week. That will be posted on Discord. And if interested, please indicate so in the project applications channel, or on the form in the project applications channel. Right. Thank you.
All right, hey everyone. My name is Harris Kassar. I am the project manager for Project Reach. Before I move on, I just want to direct anyone's attention to the chat. I just want to make sure, since we didn't mention it before, there is a link to a sign-in form. Make sure if you haven't filled it out, please do. We just want to make sure that we're able to not lose you guys to the void of online Zoom pandemic. There's also a link to our Discord. We just made the switch from a Slack over to Discord, and so that is going to be our main form of communication for Bruin Space overall, and also for Reach, which I'll talk about here in a second. So yeah, please do that right now. I guess without further ado, Project Reach. So like I said, I am the project manager. I should have probably also well, I'll give a shout out to Andy Pang. He is the chief engineer of Project Reach. I think I might, his information is later on in the slide, so we'll come back to that. So Project Reach is Bruin Space's project that is concerned with specifically amateur rocket payload systems. So for the past 2 years and on into this year, we've been working on a project called Spartan, which is essentially a modular design satellites that aims to, in the future, support scientific and engineering payloads. We've been developing this in the CubeSat form factor, and for those who may not be necessarily aware of what that means, a CubeSat is essentially a miniature satellites. It's been sort of the main way and main entrance point for university teams to perform space development. So Project Reach is trying our best to conform to those CubeSat requirements as best as possible. So like mentioned on there on the slide, Reach is a massive interdisciplinary effort. We need people who are passionate and willing to learn and work on structural design, as well as software engineers to build flight software, as well as people who are developing our electronics and our PCBs, also those who are willing to learn radio communication and allow us to actually downlink our flight data during flight, as well as those who are willing to analyze our data once it's downlinked. So we need everyone from literally every single discipline in the engineering world to join us. Next slide, please. Thank you. So I included this as sort of an image from our critical design review, which we did this past winter, I think. Essentially, this is a blown out CAD of our current design of Spartan. For those of you who are familiar with CubeSats, this looks very much like a 3U CubeSat because that's what we're trying to aim for. So you can see a couple different numbers pointing to the different areas. Our structures is our entire area, and I'll talk a little bit more about the sub-teams that are corresponding to these sections here on the next slide. We have our electronics power system, which is the very bottom board, as well as that back plane at the very bottom of the CAD, as well as our battery pack, which is that dark gray thing right in the middle. We also have our essentially our main flight computer board, which is our command and data handling board. That's the second from the top. We have our avionics board, which is holding all of our sensors. We aim, so we want to have sort of a purpose to this CubeSat, not only providing a platform for payloads to essentially be flown into high altitude, but also we want to provide a very basic payload or a very basic payload system health and avionics data. So that includes flight telemetry as well to be downlinked. We have our communications board, which is how we're going to be performing that downlinking, and then the payload. So for the past 2 years, this payload has sort of been a dummy payload. I'll just mention it here, and I'll talk more about it in a bit. But we are looking to actually change that dummy payload, which was originally just going to be some weight that we would throw in there or something like that. Maybe, I don't know, a Bruin Space plush or something like that. Instead, we're looking to change that into an entire new sub-project, which, again, I'll talk about in a second. So next slide, please. So I'm going to do a very brief dive into the different sub-teams that we have. So we have the structure sub-team, which is led by Alyssa and Alyssa. So the structure team, like I mentioned before, they are really focusing on the actual structure that's surrounding all of our critical components inside of Spartan. So if you're looking to join the structures team, you'd be very interested in learning how to CAD in SolidWorks, as well as down the road developing documentation for the eventual assembly and manufacturing of Spartan, which unfortunately we aren't able to do right now. But we are hoping and we know that we have a bunch of work ahead of us to perform or to set up that documentation, so our manufacturing process come maybe the end of winter quarter, maybe spring quarter, who knows, will be nice and smooth and an amazing experience for those who want to get involved. For the electronics team, that is led by Andrew Fantino. He and his team are working specifically to essentially deliver all the power to our flight systems and our supported payload. Right now, we are very much electronics, even though you typically think of electronics as needing the hardware, we are definitely still in the testing and design phase of our electronics team. So there's definitely still a lot more work to do that we can do in a remote fashion. That includes PCB design or printed circuit board design inside of Altium and Eagle, as well as LT Spice simulation software, essentially for allowing us to actually test parts without us having to actually have the hardware in front of us, which is great for the situation that we're in. So for our software team, that is led by Kevin Lee. our software is not only working on flight software specifically for Spartan, but also working on creating a modular sensor driver library that can be used for future Reach missions or future Bruin space missions in general. So to kind of give a little bit more background on that, essentially we are really focusing on building out the flight software and that sensor driver library inside of Git and GitHub. So we're still at sort of the entry level phase for really building out the repository. So this is an awesome experience for people who are for people with no experience or even just a little experience or even a lot of experience to jump in on a relatively large size project for software. So we're mostly coding in C and C++, and super important for those really anywhere in the engineering world to learn version control via Git and GitHub, and we're really focusing on actually building our documentation through Git and GitHub more than we have in past years. So next slide, please. So now we have our two last but not least sub teams. We have our communications sub team. This has sort of been jumped in and out of a sub team right now. Currently, in its current state, it is a collaboration between our electronics and software sub teams. So they are the ones who, remember, power all or enable our abilities to actually downlink all of our data, send it from Spartan, which is flying on an amateur rocket, all the way down to our ground station. So for people who want to learn about ham radio, maybe get a ham radio license, as well as work maybe potentially more on the software side of things, figuring out that data packet construction and how that is sent from Spartan's radio system down to our ground system. Those are the people who would be very interested in joining the communications sub team. We are still very much in the research phase of our communications sub team. We have done a little bit of research on current antennas and how we can work on building software to support the communication system. So that is a very important part of our project, and there's still a lot of work to be done, and all that stuff can definitely be done remote. And then we have our last sub team, which is our operations, that is headed by Karthik Puella. So operations is sort of two different sides, and not only does it like I mentioned before, not only does it focus on the data processing and analysis side of things on the ground station, but it also works on the mission operations. Once Reach gets much closer to actually launching Spartan, which we were last year until pandemic happened, and we're hoping again we can try again this year. Mission operations, the operations team will be very critical to making sure that we hit our deadlines and actually launch on our amateur rocket. So in terms of skills, I specifically listed here some more of the software side of things, but also experience in, or if you're willing to gain experience in more of a mission design side of things, this is a great team to join as well. People who are willing to do software as well, very interesting, very important team to join as well. If you go to the next slide. Oh, actually, so before I jump into the COVID-19 adjustments here, I actually think I forgot to mention the payload sub-project. So for the payload sub-project, we are currently putting it as a part of our structures sub-team. However, the payload sub-project you can think of as Project Reach is as a whole going to give you the people who are interested to a list of requirements. As long as you meet those requirements, you can be confident that your payload, whatever it may be, will be sent on the next amateur rocket, a collaboration we do within the actual Spartan payload system. So in terms of people, we're looking for that. And again, we'll talk a little bit more about this later, which I'll mention on the next slide. But for those people, it could be literally anyone. If you want to build something that's within a 1U, maybe like a 10 centimeter by 10 centimeter cube, and you want to make anything, maybe just a simple data logger, and you want it to be sent into to the high altitude, this is a perfect opportunity for you to sort of dive in and kind of do your own project while still working on our team. So again, I'll talk a little bit more about that later. So COVID-19 adjustments, I've kind of been alluding to this the whole time, and so have the other projects as well. So everything will be done remote. We still have a lot of work that can be done in this remote setting. So all of our meetings will be conducted via Zoom / Discord. It depends on the sub-team, depends on the sub-team lead. And so like I mentioned before, each sub-team has a lot of work and amazing experiences that can be done remotely. So if you go to the next slide. So what exactly is that work per se? Well, I guess, yeah, before I dive into that, so while Overseer is our entry-level project, Reach is considered more of our mid-level projects. However, we're still very beginner-friendly. Really, it's as long as you have that passion to dive into Project Spartan, into Project Reach in general, you can really find a place inside Reach. In terms of time commitment, I constantly say this as well because I hate putting an hours per week binding to Project Reach, but you really get what you put in. We are all students here. We all are learning together. We all are also taking classes through UCLA, and so we do understand that certain weeks maybe a lot more packed than others, potentially around midterm season, closer to finals as well. But we're all here to learn. We're all here to have a great experience. And so you really do get what you put in. But if I had to bind a time thing, I would say you're looking to at least put in about maybe 2 to 3 hours a week at least. Whereas one of those hours, maybe 1 to 1.5 of those hours is specifically reserved to weekly sub-team meetings and all hands meetings. So are you interested? You want to learn more? Our first all hands / interest meeting is going to be held sometime next week. Potentially we're looking at Wednesday right now, I think. So make sure you apply through the Bruin Space application, which I believe we'll talk about later in the slideshow presentation. So yeah, if you're really, really excited about the project or you just want to come check it out, come check us out at that meeting. Oh, and then if you go to the next slide, I think I might have my contact information as well. Yes, yeah. So there's my personal email. There is Andy's personal email as well as our Discord tags, which again strongly encourage you to join the Discord. That is how Project Reach will be doing all their communication as well as Bruin Space overall. So yeah, thank you so much for listening.
Yeah,
and
just an introduction.
Yeah.
I'm Andy, the Reach Chief Engineer. Harrison put these slides together, which is why he gave all of them. But I'll definitely be hanging on the Discord for questions afterwards if Harrison ends up being busy.
Thank you, everyone.
All right, before we move on to Rapid, I'm going to really quickly restart the share because there has been some last minute edits in the last part of the slides. I have too many windows open. Okay. That button. And I did that. All right.
Hey y'all, my name is Ching Lee. I am a 4th-year physics major and I am the project manager for Rapid. With me is Justin. Do you want to introduce yourself, Justin?
Sure. Hi everyone. My name is Justin Neal. I'm a 4th-year aerospace engineering major and I am the chief engineer of Rapid.
All right. So what is Rapid? Our current mission is centered around the MIXI engine. MIXI, which stands for Miniature Xenon, is a prototype ion engine developed by the WORDS lab of UCLA for possible. Oh my God, I'm blanking right now. I'm sorry. I've had a long day. MIXI is an engine that is slated for possible deployment on a payload, so that it can be used for the translunar journey from Earth to the Moon, or a possible journey to Mars. As many of you hopefully know, ion engines are extremely fuel efficient, but lack a lot of the power required to leave Earth's gravity field. So, which is why they are best slated for long-term journeys, such as the ones that I've described. As you can also see, these things are also pretty small. So, we can hopefully fit maybe one or two in a 3U chassis. And so the mission for Rapid right now is to, Justin, is to develop a 3U CubeSat capable of supporting the MIXI for technology demonstration. Currently, the MIXI is at a very early stage. However, with this deployment, we will hopefully bring it to at least TRL7, which means it will be slated for possible use in general CubeSat and other aerospace applications. So below, you see a brief system top-level diagram. You are not required to know all of this. One of the things that being PM of Rapid allows me to do is to cherry pick my team so that they're one of the more experienced in Bruin space. It is worth noting that you do not have to know all of this. If you do choose to apply and you're accepted, you will be responsible for maybe a small portion of this diagram. As project manager and in conjunction with my chief engineer, it is our duty to understand all of this and to organize it in such a way that it makes sense. However, this is pretty standard for a spacecraft. You have the basics of everything that you need: power, communications, an actual payload, which in this case doubles with our propulsion unit. But if you ever wanted to work on like a large complex project that will be going to space, Rapid is your best opportunity to do so. Well, within the next few years, anyways. Justin? And below we see a brief model of what our design has evolved into. So as you can see, the payload is slated at the very back, which is at the very top for this particular graph. It's relatively small. It'll fit in a 1U, which is 10 by 10 by 10 centimeters. And the rest of our systems will be basically slotted into the rails along the inside of our spacecraft. What isn't shown here is the large amount of solar panels and antennas that we'll need. But hopefully with you guys coming onto the team, we'll have more than enough manpower to fully develop this mission and to hopefully get it to launch within the next few years. So our current status is that we will be moving, we just finished our preliminary design review, and we will be moving on to a more complex critical design review. In the process, iterating our design, making improvements where we see fit. Because of COVID this year, we will be moving forward with heavy emphasis on simulation and virtual development. So if you're interested in systems engineering and you want to do MBSE, this is your place to do so. Simulations in SolidWorks, electrical block diagrams, MATLAB simulations, all that good stuff. It is worth noting that additionally, Rapid has been granted the use of a full-time computer to help develop and to run these simulations. So we are definitely in a good place to potentially push our design ever more quickly into the future. For this year, we're hoping, given that COVID may or may not die down later on this year and the next, we're hoping to go into a critical design review, which means that launch will only be a few short years away in the spring. and hopefully we will have all the components to build our actual an actual model of our spacecraft by the end of the academic year. This will be used for testing, iterations on design, etc. It'll also be, quite expensive. So, rest in peace, all the time I'll need to develop this. But in any case, hopefully by my graduation, well, me and Justin's graduation at the end of spring this year, we will be able to say we built a CubeSat that will potentially fly after we test it in all sorts of nasty conditions. And so the next thing that you might be asking is, how do I join? Or maybe this project's too complex for me. But in any case, these are the main areas that we need help with. So feel free to apply. It is worth noting that it never hurts you to apply. It just makes us a little bit, it just impacts us a little bit as officers and project leaders, because we have to sit through and sift through all of the applications. It is also worth noting that the application process is fairly simple. And even if you don't get into Rapid, you are still eligible for any of the other projects. And you are also eligible to reach out to a sub-team lead in order to try and become a shadow for Rapid. And the sub-team lead will grant you work as it comes through their desk. So over there on the right, you see in contact information for Justin and I. Feel free to reach out to both of us on the Slack. We're mostly friendly. Justin doesn't bite half the time. But always please do apply. As always, you can join multiple teams and even projects if you so desire. However, the one thing I will say to warn you guys on that fact is, if you do join multiple teams or multiple projects, you are responsible for keeping up the work of said multiple teams and or multiple projects. So just keep that in mind. Our first informational meeting will be held on the Justin Stop Panicking. Please stop panicking. You just ruined the big reveal, man.
Sorry, I keep left click is what moves stuff.
But anyways, we will have our first informational meeting next Monday at 6 p.m. Pacific time. If you're on the Eastern Seaboard like me, it sucks, right? 9 p.m. I don't want to be having a meeting right now. Like, come on. But yeah, no, feel free to reach out. We'll definitely need lots of people to help push this project into the future. And don't be afraid to reach out and ask any questions. And without further ado, we have the top level team for Bruin Space has a surprise. So over the summer, we've been working with the WERS lab to develop a model of sorts. As you guys know, TIE Fighter from Star Wars actually stands for twin ion engines. And one of the big things that the WERS lab is currently developing is MIXI, which is an ion engine. So we thought we'd like to get sued by Disney. So we're going to make a model and then we're going to try and fly it. And without further ado, this is the kind of work that we have, the kind of results that we have right now. Maybe we should pair this with something like EDM or something. Just like heavy bass. I don't know.
So yeah, you guys can see that we're putting 2 MIXI thrusters on this model, along with all the avionics that go in the orb in the middle. So yeah.
It is a cockpit, Justin. Speak clearly. But yeah, on our how I like to run projects is I try not to take things too seriously. Feel free to reach out with and crack jokes. One of the big things that we're trying to encourage this year with the Discord is a better sense of community and a little more relaxed of an environment. So feel free to post whatever dank memes you have. Anyways, I'm out.
In the appropriate channels, of course.
Unless you're a leadership, then you can do whatever you want, basically.
Stop it. All right, moving on to some more admin stuff. We're going to go over the different administrative teams here at Bruin Space, because you're also welcome to join those and help get down to the nitty-gritty bits of what makes this club actually work. So a brief introduction. I'll let each officer introduce themselves, assuming they're here.
Yeah, hello everybody. I am Christopher. I am president, and yeah, so, yep.
Hello again. I'm still Justin. I introduced myself as the chief engineer of Rapid, but I'm also the internal vice president of Bruin Space.
Yeah, it's worth noting, guys, and I'm going to butt in here for a second. But if you'd like to join the any of the leadership teams, you know, we're always overworked, and if you want to contribute, we probably won't say no.
And hello, my name is Yu Chen, and I am the external vice president.
Hi everyone, I'm Janine Lee. I'm one of your marketing co-vice presidents. Angela couldn't be here now, but she should be joining us within the next hour.
And hello, I'm your finance president. To see everyone.
All right, jumping right off of that, we're going to go into internal affairs and what we do here. So internal affairs manages communication, events, and resources that are within the club. Among other things, we maintain the Discord, as well as the shared Google Drive, where we keep all of our documents and stuff. Technically speaking, we also oversee management of the lab, but obviously due to COVID, we're not doing that quite right now. The other big thing that we are working on, especially in this time of everyone being stuck at home, talking to each other through screens and cameras, we are trying to organize more social events and build a stronger community. And we just generally try to make sure the club runs smoothly, make sure all the projects have what they need, not counting finances, but, and also, yeah.
All right, so external affairs. All right, so next slide, please. Okay.
Sorry.
All right, so we handle communication. So what do? We handle communication with everything outside of the club, and when we usually, you know, keep in contact with other clubs on campus and potential corporate sponsors. And because money is always an issue for the club, our main purpose, I would say, is corporate outreach. And what we do is we develop sponsorship packages. And what I mean by that is that the sponsorship package usually means that, hey, what can we offer to these corporations in exchange for them sponsoring us? And then, and we also maintain industry contacts plus mentorships. And how do we do that? We usually try to communicate with these companies via email by trying to get in contact with them and then try to get our members internships or some sort of mentorship with individual members from some companies. And then we also arrange speaker events. And because now everything is online, we'll have to try to think of a way to try to get potential speakers in industry to try to, you know, like get on Zoom and potentially mentor some of our members. And yeah, and like I said before, we also coordinate collaboration with other clubs, and other clubs on campus include things such as Rocket Project, who we have tried to work with for a long time before COVID canceled all the plans last year. And right now we're currently looking for, our team is usually pretty small. And so right now, external is probably looking for another member. And so if you're interested, contact me in my email below. Right.
And then for finance, we are the ones dealing with getting grants for our project. So through this, we usually are working with the school through their programs. And it's good to know that what we generally do is we'll identify needs for our projects, generally, which is supplies lists, and then we will go and fill out a bunch of paperwork, and often it may result in us requiring to go in to a committee and pitching our needs to the board. This year, we intend to do a lot more of documentation. So if you're skilled with Excel, do join us and help us. So, yeah. Otherwise, feel free to contact me if you think you just want to learn a bit more about how clubs are run and how to secure funding through UCLA sources.
All right, so for marketing, I'm sure you've all seen this bear floating around our promotional material and social media, and you might be wondering why they're there. Well, this is our club mascot, Brew, as in Brew in Space. And creating Brew was part of our job here in marketing. In the next slide, I can further explain our role. And next, graphic design. So if you just felt some pain in your soul upon seeing this, you might just be the right fit for marketing. Next, please. So because graphic design is a huge part of what we do, we use mostly Canva, which is a free online program. We use it to make flyers, logos, other forms of branding for the club, which I can guarantee looks a lot better than what you just saw. Our job is to spread the word of the club and uphold its brands and its values through various forms of media. Speaking of which, the marketing team also maintains the club's social media presence on Instagram, Facebook, and just a little bit of Twitter. Moreover, we do a lot of illustrations and art, mostly for posters and our promotional material. And of course, we manage the club's email blast, which we are aiming to make weekly. And this is for all members and interested parties to provide any updates and events and socials. And if anything of these, or like any of these listed topics sounded interesting to you, maybe you should consider joining our team. The workload isn't very intense and all of our work can be done remotely. If you have an eye for visual design or fondness for social media, maybe, we would love to see you on our team. And feel free to contact either Angela or I through our email or on Discord. And yes, the slides will be coming out on email later on.
All right, so that's it for the informational session. If you're planning on leaving right away, wait just 1 second. So below is a link to the Discord. That'll also be posted again in the chat. Additionally, the project application will be posted here in the chat as well as on Discord. We're now going to do an open Q&A session also on our Discord. There will be a couple people sticking around on the Zoom meeting in case you're not familiar with Discord and don't know how to get started with that. So there'll be some people sticking around to help you get on our Discord and start talking to people. But for new members and people who are interested in the club especially, this is a great opportunity to talk with some of the project leads, talk with normal members, see what the club's like, get a feel for, things that might be a little more specific to your interests. And with that, I hope to see everyone on the Discord and have a good evening. Thank you for coming.
Also, I have unlocked the project applications on the Discord, so we'll also be emailing that out. But if you want to go ahead and get that filled out and you're already on the Discord, go take a look.
All right, people interested in Reach and Reach leads who still want to stay on, I'll see you on the chat that I'll be making on the Discord.
People who are interested in getting onto Rapid, I'm going to take 5 minutes and then I'll be around to answer questions.
If anybody has questions about software or operations in both Reach and Rapid, you can send some questions towards me.
Karthik, are you doing that on a channel in the Discord, or are you? I think we're just for here. We're just doing onboarding for people that have Discord questions.
I don't know. Let me mute Discord. Give me 1 second.
Oh, sure, yeah.
So is the problem that Discord is making noise on the chat?
No. We're so on Discord. We can open up as many chats as we want to, and people can bounce between them without having to move between breakout rooms or have everyone talking in one place at the same time.
Uh-huh.
Yeah, so you can just go ahead and create, if you want to just create a chat room there for general software questions, that would be great. People can just hop in there directly. And so yeah, we're just keeping the Zoom for like just if people have questions about how to use Discord, because like we know that it's new and kind of unfamiliar. But yeah, you should make sure you have, oh wait, you may not have permissions for that, but I can make you a channel.
Okay, that'll be cool.
Just software general, or what do you want to call it?
Let's call it operations and software.
All right, it's ready for you. So yeah, you should see them in the chats category now, where all the other voice chats are popping up.
Cool, yeah. So I'm gonna get off this meeting and be over there.
Okay, cool. Thank you so much.
All right, bye guys.
Oh, I was about to answer that guy's question and then he left.
Oh, shoot. Well, it's now just us. So I feel like we should go ahead and hang out maybe for like a little bit, because we had the meeting scheduled for like this entire time.
Yeah,
so,
I'm probably just gonna mute myself and keep an eye on the participants tab.
Okay.
And then hop into the Discord.
Okay. Yeah, I don't know if we I can go ahead and bounce and just be available for questions on the Discord then as well.
Yeah.
Unless you want me to hang out here.
Yeah, sure.
Okay.